Today we're going to be solving exponential equations. Here's part 1. On example 1, I have 3 to the x times 3 to the second is equal to 3 to the 8th. We're going to apply exponent rules to the left side of the equation. So 3 to the x times 3 to the second, when we're multiplying and we have like bases, the rule is we can add our exponents. So this can be rewritten as 3 to the x plus 2. Is equivalent to 3 to the 8th. I can see that my 3's are exactly the same. Well, as long as my bases are exactly the same, then my exponents must also be exactly the same. So I can actually ignore my bases completely and set my exponents equal to each other. So I have x plus 2 is equivalent to 8. Now this gives me a problem that I can solve, so I can figure out what value I can use for x to get a true statement. So if I solve for x, I'm going to subtract 2 from both sides. I get x is equal to a positive 6. If I were to plug a 6 into my original problem for my x, 3 to the x times 3 to the second is equivalent to 3 to the 8th. So this is my answer. Let's take a look at example 2. For example 2, we have 3 to the x divided by 3 to the second. According to the rules of division, as long as we have the same exact base, we can subtract our exponent. So we end up with 3 to the, and remember, it's the top exponent of x minus the bottom exponent of 2, and it's equal to 3 to the 8th. I have the same exact bases, so I can ignore my bases and set my exponents equal to each other. I get x minus 2 is equal to 8. I'm going to solve for x by adding 2 to both sides, and I get x is equal to 10. On example 3, if I have parentheses 3 to the x close parentheses squared, all divided by 3 squared is equal to 3 to the 8th, what I would do is I would apply my exponent rules to my numerator. I have this 2 that I can apply to my base of 3, but since it already has an exponent on it, I'm going to go ahead and multiply my exponents. I end up with 3 to the 2x all over 3 squared, and it's equal to 3 to the 8th. Well, now I can apply my exponent rules again. Whenever we're dividing with the same base, we can go ahead and subtract our exponents. I end up with 3 to the 2x minus 2. Remember, it's always the top exponent minus the bottom exponent, and it's equal to 3 to the 8th. Once I have this equation where I have a base and an exponent equivalent to the base and the exponent, and we have the same exact bases, I can go ahead and ignore my bases and set my exponents equal to each other. So I would end up with 2x minus 2 is equal to 8, and I'm going to solve for x. So I'm going to add 2 to both sides, draw my line, those go away. I get 2x is equal to a 10. I can go ahead and get rid of my 2 by dividing. So divide by 2, those go away. I get x is equal to 5.